Okay. We're going to work with the combination of functions. There are 5 ways to combine functions. Okay? We're going to talk about the 4 basic ones together as a group, and then we will talk about the 5th one. For our first 4 basic combinations, it is important that F and G have overlapping domains. We're going to talk about the combination of functions using addition, subtraction, multiplication, and division. In order to be able to add, subtract, multiply, or divide functions, they have to have something in common so that you can plug into both of those functions at the same time. Okay? So what I mean by overlapping domains, I'll give you a counter example. If f has a domain of 0 to infinity, okay? If f has a domain of 0 to infinity, and g has a domain of negative infinity to negative 2, I'm going to have to calibrate that. Do they overlap anywhere? No. So I don't have any numbers that I can plug into both functions, which means we can't combine them into one. Okay? Give me a timeout here. Okay, so I know that you know how to add, subtract, multiply, and divide. But what I want to show you is the notation that may be different from what you've seen. So like the sum, that f plus g of x, just means you're adding f and g together. It just looks a little funky. Okay, and same thing with the rest of these. Okay, so this is how the problems will be presented to you in your homework tonight. Okay, so don't let the notation throw you off. What I do want to point out, though, is this quotient one right here. We have this extra g of x can't equal 0. Why is that written in? Because it's the denominator, and what's our rule about dividing? We can't divide by 0. So the domains of the sum, difference, and product are going to be pretty straightforward, but we will have to be careful with the domain of the quotient because we can't divide by 0. Okay? So what I want you to do is write down the 2 functions up here. And then as a pod, I want you to write down what the domain is for f and the domain for g.
Actually,
Jackson, what's the domain of F?
All reals.
All real numbers. You were talking very passionately about that one. I thought I think you were. He was like, look at it. Okay. Okay, any linear equation with slope is going to have a domain of all real numbers. Like G. G is a linear equation that has slope. It's going to be all real numbers. Are you going to be okay?
me?
Yeah.
Yeah, I'm good. I'm just kind of hot.
Okay. Do we have overlapping domains? You betcha. So, let's just very quickly talk about the combinations, the different combinations that we can do here. Okay. F plus G of X. We are taking F. We are adding it to G. What is the sum?
X minus 3.
Which has a domain of all real numbers. You take two lines and combine them, you get a line. All real numbers. Okay, for those of you who still have your summer or your skills quiz corrections to do, hopefully this one can help you with a problem that many of us may or may not have struggled on. When you subtract two functions, please be careful. Write down the first function, but when you subtract a function, put it in parentheses. That subtraction needs to be applied to the entire second function. That was a common mistake on the quiz. This is really 2x minus 5 minus 2 plus x. Okay. Everyone all together, the domain? Wow, that was just full of enthusiasm. Okay. Next, the multiplication of two functions. Like I said, I really just want us to work with the notation today and talk about domain. I know you can do the other stuff. What do you like to call the method in which we need to go about multiplying these two together? FOIL. It's not my favorite word, but it's a nice acronym that helps you remember what you need to do. Okay? So help me out. What is our first product? Outside? Inside?
Inside.
Last. Okay. I wanted to talk about this problem specifically because the order is all strange, right? I don't know how picky your Algebra 2 teachers were, but I want these terms to be in order from highest exponent to least. So I would expect you to rewrite this as negative 2x squared plus 9x minus 10. What kind of an equation is this? Quadratic. And quadratics have a domain of all real numbers. Any polynomial. So right now we've talked about linear, quadratic, cubic. They're all going to have domains of all real numbers. Okay, don't overthink it. Okay, linear, quadratic, cubic, always all real numbers, no matter how funky it is. Okay. All right. Last but not least, we have f divided by g of x. This is actually going to take the least amount of work, but we have to think more about the domain. Okay? If we're dividing f divided by g, can we simplify that at all? It's tempting, isn't it? But you cannot. Okay? These 2's don't cancel out. Those x's don't cancel out. Okay? The only time you can the only time you can simplify a fraction is if you have terms separated by factors. Okay? So if you had 4x minus 2 over 2x plus 2, you could factor a 2 out of the numerator, you could factor a 2 out of the denominator, and then the 2's would cancel. Okay? You have to be able to factor something out to reduce it. So you can just leave it like this, which is nice. Your work is done. Okay? Well, we have to think about the domain. I told you that we have to be careful because of what feature? What did Colby point out to us?
Oh,
the denominator cannot equal 0. Okay? Where does the denominator equal 0? 2. So our domain is everywhere except 2. Everything below 2, everything after 2. This is an example that we did, first day of school? It's been a week. All right, so here's your reminder. Everything except 2, this is how you would write it in integral notation. Okay, I promised you 5 ways to combine functions, didn't I? Okay. The 5th one is the composition. Okay, and I was told by my first hour that some of you at least have seen this notation. F composed with G is also written like this, F composed with G, that little circle, right? How many of you have seen that little composition circle? Okay, a few. We're essentially taking the function on the inside and we are plugging it into the function on the outside. F composed with G, we're plugging G into F. Yeah. This first way, your textbook is going to write it like that. I will always write it like this. It's just more comfortable, and it's easy to see what to do when it's written that way. Okay? Now, okay, my board gets kind of like cut off, so I'm hoping. Okay, you guys all, this is the word of right there. Okay, go ahead and write down the definition of finding the domain, and then when you're done writing it down, I'll explain to you what it means. Okay, so I kind of have this picture here. Domain are the x's that we can plug in. So if we are taking f composed with g, g is our inside function, right? So first we're going to have to be able to take x's and plug them into g. And then we plug those numbers into f. Okay? So really, the domain of f isn't super important. Our first concern is the domain of g. We have to consider the domain of g because we only have a limited number, or if we have a limited number of x's we can plug in, we need to be aware of that. Okay? Then we're going to plug into f from those g of x numbers, right? And this is going to give us an equation where we're going to have to consider the domain. Because if this ends up being some sort of square root function, all right, the domain is going to be limited. So what we're going to do is we're going to determine the domain of g. We're going to look at the equation we get out of the composition. And wherever those two domains overlap, that's the domain of our composition. Okay? Best way to explain that is to actually have an example. All right? So why don't you go ahead and write down these two functions for me, please. Okay, so first let's just focus on finding the composition. Let's talk about the algebra involved to do that. Okay, some of you may not like this notation. That's fine. I don't have a problem with that. Write it like this: F composed with G. Okay. I like writing it like this because we can visually see. All right, let's change G of X. G of X is square root of X minus 3. Okay, now that is what we're plugging into our f function. So our f function is x squared minus 4. Anywhere there's an x, we're replacing it with what's inside. So instead of x squared minus 4, we have radical x minus 3 squared minus 4. Wherever there's an x, we replace it with g. Yes, they cancel out, which is nice, right? They cancel out, so we are left with the x minus 7. Now, some of us want to say, cool, linear function, domain of all real numbers. But it's not that simple. Okay? we have to consider the domain of the function we plugged in as well. Okay? So first, we have to consider the domain of g, because that's the function that we're plugging in first. Okay? What is the domain of g? Here's where our transformation of functions really come in handy. G is the function radical x minus 3. You can either graph that in about 10 seconds or draw that visually in your head in about 10 seconds. Okay? Either jot it down if you need the visual or think about it in your head. Okay. Robert, what's our domain for G? Good. It's 3 to infinity. We have a square root function that is shifted right 3. That's what you should have jotted down or visualized in your head. Our domain is 3 to infinity. Okay? Now, our result is linear. And we know that that would have a domain of negative infinity to infinity. But to get there, we have to plug into g. So since g is restricted, we have to take that into consideration. So what we're going to do is we're going to look at both of these domains and see where they overlap. They overlap at 3 to infinity, so that's what we're going to go. Okay. Now sometimes it could be the other way around. The composition is more restricted than G. Still want to go with where those two overlap. Did you get your question answered? Yes.
So like, if it was g of f of x, would you find the domain of x?
You would first consider the domain of f, and you would compare that to your result, and where those overlap, yes, that would be your domain. Okay? You have to consider both. Okay? Okay, so on your gold sheet, you should have these problems. Okay? Don't write them down from here. Just look at your gold sheet. Save you some time. We have 11 minutes left in class. Oh, no, 9. Sorry, I had the wrong number. 9 minutes left in class. That's still a good chunk of time to get some problems done, especially these first few when it's like the abstract, okay? You could either be working on your book homework, or you could be working on your problem set or quiz correction. You have 3 different things you could be working on. Nobody should be sitting there without math in front of them, okay? I am here to answer questions if you have questions about anything.